Hello class, today we'll be talking about 9.1, System of Linear Equations. So the first topic will be linear systems. Then we got substitution method, elimination method, special systems, and linear systems with three unknowns, or three variables. So when we think about linear systems, so it's going to be a linear equation or a first degree equation in unknowns. Now, looking at this right here, it's just basically saying that we're going to have as many things that's going to be first degree. So let's just say if we had x plus y plus z is equal to some b. Now, what is all is it saying is saying we may have x, we may have y, we may have z. It could actually be longer, but in this case, we're gonna do x plus y, then we'll do x plus y plus z. Now, also they can use a plus b plus c. They can use different variables. So don't let that fool you, but just know they all use the same. So, a set of equations considered simultaneously is called a system of equations, and the solutions of the system of equations must satisfy every equation in the system. So if you find x is equal to 5 and y is equal to 4, they both equations have to be satisfied by that. If all the equations of the systems are linear, then the system is a system of linear equations or a linear system, just the way naming, all right? So the possible graphs of a linear system are in two unknowns and as follows. Now, when we think about it, if we graph two linear systems and they cross at a path, that means they have one point of intersection, so that system would be consistent and independent because we end up with what? An answer for it. So that'll be the single order pair of that solves the system. That's what they both have in common because that's where they both cross on. That's where they both intersect at. Now, that's when you have your actual answer. Now let's look at this. If they're parallel, that means the answer is no solution because they never do what? Intersect. This system is inconsistent and it is what? Independent. Now, let's say we have a graph and the system are the same lines, just multiples of each other. This system has infinitely many solutions because it doesn't matter what you put in there, both of them would be satisfied. And what? The system is consistent, but they both are dependent systems because they're the same thing. They're not independent of each other. They depend on each other because they're the same line. So, first method we're going to look at is substitution method. In a system of two equations and two variables, the substitution method involves using one equation to find an expression for one variable in terms of another. It says, and then substituting into the other equation of the system. So we're basically going to solve for a variable, then substitute that variable back into the previous equation. So let's do that. All right. So the first thing I like to do, I'll look at the easiest one. I think 2 is the easiest one to manipulate. So I have negative x plus y is equal to 3. Now I'm going to just solve for y. So I'm going to have 3, y is equal to 3 plus x. All right. Now what I'm going to do is take this and plug it into for y. All right? So plug in. All right. So when we plug in, I'm going to have 3x plus 2 times 3 plus x is equal to 11. Therefore, I got 3x plus 6 plus 2x is equal to 11. So I'm going to do like terms, which is these two, and that'll be 5x plus 6 is equal to 11. Now I'm going to have 5x is equal to 11 minus 6. So 5x is equal to 5. So x is just equal to what? 5 divided by 5, which is 1. Now, the thing about that is, once you find x, you can now plug x in for x right here. Do not put it into one of the originals, just put it into the one that you solved. So therefore, you got y is equal to 3 plus 1, which is equal to 4. So now you found x and you found y, right? Because you got y is equal to 4, right? So you got what? The ordered pair should be what? 1, 4. That's the one that solves the system. So make sure when you're doing these, you make sure that you keep your order. If you see how I organized it, I didn't bunch it up. I used some actual space to solve it. So elimination method is another way to solve two systems. Now, when you deal with elimination method, you're basically figuring out something that you can eliminate. You want to eliminate one of the variables first and then solve for the other variable. All right? And you're going to have to do this twice. Or for the second time, you can use substitution. But you'll see what I'm talking about when I start this. Okay, so we have the system as 3x minus 4y is equal to 1. Then we have 2x plus 3y is equal to 12. So me personally, I want to go ahead and eliminate the x values. But to do this, I have to multiply both by a common factor. So I'm going to multiply the top one by 2 and the bottom one by negative 3. So when I multiply these things, I'm going to get 6x minus 8y is equal to 2. Then I'm going to get negative 6x minus 9y is equal to negative 36. Now, elimination method basically saying I'm going to add the 2. So you know the 6's cancel. Then I'm going to have negative 17y is equal to a negative 34. So now I'm going to get y is equal to, and if I divide that into it, I'm going to get 2. So now I'm going to take this y, then I'm going to plug it into my first one. So I'm going to have 3x minus 4 times 2 is equal to 1. So I'm going to have 3x minus 8 is equal to 1. So this going to be 3x is equal to 9. So x is equal to 3. So therefore my ordered pair would be 3, 2. So just basically understanding this method. So let's look at this one. So this says solving inconsistent systems. So let's look at this inconsistent system. Now, let's just say we wanted to get rid of our x's. And you ain't always got to get rid of x. You can get rid of y. It's up to you. So I'm going to multiply the top by 2. So therefore, it's going to be 6x minus 4y is equal to 8. Then I'm going to have negative 6x plus 4y is equal to 7. Now, when you eliminate, if you notice both of these eliminate, so you get 0 is equal to 15, which we know that they're not equal, and that's why we call it inconsistent, because you get what? You get an untrue statement. You get a contradiction. You know that 0 is not equal to 15. So this will be one of the ones that are no solution. Or you may see empty set, because this is what? Parallel. All right? So just keep that in mind. So let's look at this. This is going to be a system with infinitely many solutions. So when we look at this, let's say if we want to get rid of y, you multiply by 2. So therefore, I'm going to have 8x minus 2y is equal to negative 4. Then when I multiply the 2, it's going to be negative 8 plus 2y is equal to 4. And when I do my math, this will give me 0 equal to 0, which is a true statement. Now, it's infinitely many solutions, but now, the thing is when you deal with these type of problems, all right, when you have infinitely many solutions, what they're going to do is they're going to ask you to find them in respect to x and respect to y. So what I'm going to do, I'm going to show you what both of them look like. To find in respect to x, all right, so let's say if we know we got x here and we wanted to find what y is. So we got negative 4x plus y is equal to 2. So I got y is equal to what? 2 plus 4x. So my y value is equal to 2 plus 4x. So it'll be just 2 plus 4x here. You would just have them in respect to the variable that they asked you for. So it could be this one, or it could be, they could be asking for for y. So we can use the same ones, but we just can move some stuff around. So I'm gonna do this one in a different color. So put it back red. All right. So if we were doing in respect to y, all right, so let's say if we use the same thing, we have negative 4x plus y is equal to 2. So we could just do what? Negative 4x is equal to 2 minus y. So x is just equal to 2 minus y over negative 4. Now, if we were to look at this, we can actually reduce this. So x is just equal to what? Negative 1/2 plus 1/4 times y. So therefore, I can actually put that in as 1/2 plus 1/4 y. So whatever value I put in for y, it'll give me what the value for x. So we got one in respect to x and one in respect to y. So if you see these, you know what they're actually asking for. Now, that's what this is saying right here, all right? So if you think about it, it's just basically saying, it says what? In the algebraic system of example 4, we wrote the solution set with variable x arbitrary. So it says we could also write it as what? Y arbitrary. So I showed you how to do it both. And the way that they wrote it here, they just didn't simplify it. They just didn't separate it. All right, so just keep that in mind. Now, let's look at a system with 3 equations, all right, and 3 unknowns. Now, me personally, I try to find the easiest ones to eliminate first. So I'm going to use these two first, all right? Because I can get rid of what? Z. So I got 2x plus y minus z is equal to 2. Then I have x plus y plus z is equal to what? 2. I'm about to add these two, so I'm going to get 3x plus 2y is equal to 4. Now I have to do 2 more. So I'm going to do it in a different color. So to get rid of, I'm going to do these 2. I'm going to do 1 and 2. But I'm going to have to multiply the bottom one by 6. So we're going to do it again. So it's going to be a 3x plus 9y plus 6z is equal to 3. Then we're going to have 12x plus 6y minus 6z is equal to 12. And then we're going to add this. So this is going to give me 15x, and that's going to give me plus 15y. The z's cancel, and it's going to be 15 plus equal to 15. Now, if all of them have 15s, you know you can do what? Factor out the 15s. So this is nothing but what? X plus y is equal to 1. All right? So therefore, x is just equal to 1 minus y. So therefore, I'm about to take this and plug it in here. So therefore, so I'm going to have, and let me change colors. I'm going to put, so I got 3 times 1 minus y is equal to, plus 2y is equal to 4. So 3 minus 3y plus 2y is equal to 4. So we got 3 minus y is equal to 4. So I got negative y is equal to what? 1. So y is just equal to negative 1. So since I know y is equal to negative 1, I also know what x equals, because I can just go and plug in the y here. So x is equal to 1 minus a negative 1, which is just equal to 2, because it's going to be 1 plus 1. And also, since I know, and I'm going to go ahead and change the color a little bit. Since I know that, if I know x and I know y, I can just plug it into this one right here. So it'll be what? 2 plus a negative 1 plus z is equal to. Now, 2 plus a negative 1 is just 1 plus z is equal to 2. So z is just equal to 2 minus 1. So z is just equal to 1. So when I write the ordered pair, it's just going to be 2, negative 1, 1 for my ordered pair. Remember, you have to write it in terms of x, y, and then z. All right? Make sure you follow these steps. So you use elimination method. You got to use elimination method twice. Then you can use the substitution method or elimination method, however you want to do it. Substitution just usually works a little bit better. So let's look at these. So when you're solving these, let's see a elimination method. So let's say we multiply this by negative 3. So I'm going to have negative 3x plus, well, minus actually, minus 6y minus 3z is equal to negative 12. Then I'm going to keep my bottom as is. This gets rid of the x's, so this will be negative 7y. Then we will have what? Minus 7z is equal to what? Negative 21. Now, basically, this is just equal to what? So everything is negative, so I can just factor out a negative 7. So this is y plus z is equal to what? 3, right? So keep that in mind. So let's look at what we got. So I could put y plus, well, y is equal to 3 minus z. So I'm going to take that and I'm going to plug them into both of the equations because I only got two equations, right? So this will just be x plus 2 times 3 minus z plus z is equal to 4. And I'm going to solve this. So this will be x plus 6 minus 2z plus z is equal to 4. And this will be x. And then this is going to wind up being plus 6 minus z is equal to 4. Now I'm going to move that 6 to the other side, so it's going to be just x minus z is equal to 4 minus 6, which is negative 2. All right. So now I have a 2 by 2, all right? But now I'm going to plug it into the other one. So I'm going to change colors so nobody won't get confused. So now I'm about to go ahead and put into this. So I got 3x minus, and then I'm going to plug in what y is, which is 3 minus z minus 4z is equal to negative 9. So I'm going to have 3x minus 3 plus z minus 4z equal to negative 9. So I'm going to do like terms. So we got 3x minus 3. Then we have minus 3z is equal to negative 9. Now I'm going to do what? I'm going to go ahead and add the 9 to the other side. So this would just be 3x minus 3z is equal to negative 9 plus 3, which is negative 6. Now, we see that all of them have what? 3's. All right? We got 3 here, negative 3 here, and then we got negative 6. So, I'm going to have x minus z is equal to what? Negative 2. I just factored out a 3 and divided it to the other side. So now I have 2 equations, 2 unknowns. Now the y we gonna get that later once we find what z is. So let's look at what we have. So let's look at what we have. If we add these two together, so if I were to add those two together, it'd be, so if I got x minus z is equal to negative 2, and x minus z is equal to negative 2, and let's just say if I multiplied this by negative 1, right? Negative 1. We know they're the same equation, right? So we know we'll get 0 equal to 0. So what we got to do is we got to put it in our arbitrary case. So the first thing we found was y, so why not put it in terms? So now what we want to do is just put it in terms of z, all right? So I'm going to put all my stuff in terms of z. Now, it'll tell you exactly which one to put in terms of. But I know that my y is equal to 3 minus z. Now, all I got to do is solve this one. It'll just be x is equal to z minus 2. So it's just z minus 2. So I just put it in terms of z. Now, you can put it in terms of whatever, but the thing is you want to make sure when you have an arbitrary case like this, you want to make sure it's going to tell you exactly what they want you to put it in. This particular question, you know, it just basically gives you the system and it tells you to go for it. But in your question that you'll be asked, you actually have to find what it is.